Alright, good morning guys, or whatever time of day you happen to be watching this. Welcome back to class. We are doing 8-6 today, solving rational equations. So we've done multiplying, dividing, simplifying, adding, subtracting, all that stuff. And now today we're actually going to be getting values for x. I thought we'd start class a little bit differently. My doggos really wanted to help out. Speak. And so my dog Brady is here, and she said, I'll teach class. Speak. But I'm not sure that her speaking will translate. So I'll do class today, but there's a cute picture of doggos for you. So today we're solving, which means we're starting with an equal sign, and we want to get x by itself and have x alone. Which means we want to get values for x. But when we do this, we want to make sure that at the end, the answers that we get work. So you know how we were doing all those restrictions for multiplying, dividing, simplifying, adding, and subtracting? We want to do those restrictions here as well. So that is what we're going to do. We're going to start by solving. So when we solve, the first thing we want to do is get rid of the denominators. So to get rid of the denominators, we first need to factor everything like we've been doing in every single problem that we've done. So we have x over x minus 3, that doesn't factor, plus x over x plus 3, again, doesn't factor, equals 2 over x squared minus 9. Now that does factor. That's a difference of squares. So that's going to be x, oops, there's my dogs. So that's going to be x plus 3. X minus 3. So in order to get rid of the denominators, we need to multiply all of our fractions by the denominators. So we want to account for each and every denominator that we have. So that means the x minus 3. So that'll take care of this x minus 3 as well as that x minus 3. So even though it's there in two different fractions, we only need to write it once, as long as it's not repeated in one single fraction. Because if it's repeated in one single fraction, then we need to write it more than once. But if it's just in multiple fractions one time each, then we will just write it one time. So the other factor we have is the x plus 3. So that's going to take care of the x plus 3's. So we have an x plus 3 here, so it'll take care of that one. And then we have it in another fraction as well, so it'll take care of that one. So we just want to make sure that whatever factors we have in the denominators of our fractions, we put outside the big parentheses. And then we're going to take those factors and we are going to multiply them to each part. Whether it's a fraction, whether it's just a number, everything's got to get multiplied by that. So, and we're just multiplying the top because we're not putting anything in the bottom. We're trying to get rid of the bottom, so we just want to multiply by the top. And since it's an equation, it's okay that we just multiply by the top as long as we do it to every single part. So in the first one, we'll have x minus 3, x plus 3 over the x minus 3 plus x minus 3, x plus 3 over the x plus 3 equals 2x minus 3, x plus 3 over the x plus 3, x minus 3. So now that we have that, we've distributed it to everything. Now we want to cancel the denominators. So in the first one, we have x minus 3 and x minus 3, so we want to cancel those out. In the second one, we have x plus 3 and x plus 3, so we want to cancel those out as well. And then in the last one, we have x minus 3, and x plus 3, x plus 3. So we should see that each denominator got canceled with stuff that we put into the numerator. That's why we multiplied by that stuff, so that that could happen. So then we're going to write what's left over. So we have x plus 3, plus x minus 3, equals to just a 2 on the other side. So now we have all the denominators gone, which is great. Now we need to work on actually solving this. So now this is a regular algebra problem. We're going to start with distributing our x's Some of these steps you can combine, and if you want to do that, that's fine. Just make sure that you're staying organized as you do that. So we'd have x squared minus 3x, and then that equals 2. So we combine the x squared, so that's 2x squared, and we combine those 3x's as well. But kind of nice here, they actually end up canceling each other out. So we just are left with 2x squared equals 2. So then we want to divide by 2, which gives us x squared equal to 1. So then we just need to get rid of the square by square rooting. So x is going to be plus or minus 1. So we have two answers, positive 1 and negative 1. But when we do that, we need to check and make sure that that's not our restrictions. Because if it's in our restrictions, then we need to throw it out. So our restrictions here should just match what we had up here, what we multiplied by. So x minus 3 not equal to 0 and x plus 3 not equal to 0. And from that I can see that neither one of those is going to give me plus or minus 1. So that means those are okay, because that would be x not equal to 3, x not equal to negative 3. That's none of my answers, so that's good. That's a viable answer on both of them, the two solutions. Again, any questions that you guys have, please send them my way. If you need to pause the video at any point or go back, it's your time. You do that as much as you need. If you need more pictures of my doggos, I can always provide that. All right, so we're going to follow the same thing here. We want to factor first, so we have x minus 1. It's a trinomial, so we want our two parentheses. And we want two numbers that multiply to 2 and add to 3. So 2 and 1 will multiply to 2 and add to 3. And then the second one's not going to factor at all, and the last one also doesn't factor. So now that we have everything factored, we want to multiply by our denominator. So in the first one, we've got x plus 2. So that's going to take care of that x plus 2 and that x plus 2. And then we also have the x plus 1. So that's going to take care of the x plus 1 here and the x plus 1 there. We don't need to write it twice unless it's repeated twice in the same fraction. So now, give myself a little more space. Now we distribute that through. So we're going to have x minus 1, x plus 2, x plus 1, over x plus 2, x plus 1. And we know that those are going to cancel, the x plus 2's and the x plus 1's. So if you want to do that in one step, you can do that. We have 2x, x plus 2, x plus 1, over x plus 2. We know the x plus 2 is going to cancel there. And then we have x minus 1, x plus 2, x plus 1, over x plus 1. That's a 1, not a 2. All right, so then we start canceling stuff. So we cancel the x plus 2's and the x plus 1's. We cancel the x plus 2's and we cancel the x plus 1's. When we're doing this, we want to make sure that we're only canceling within the same parentheses. We shouldn't be trying to diagonally cancel like we did with multiplying and dividing, because these are adding and subtracting. So we don't want to be doing diagonals here. We just want to be within the same fraction. All right, so that gives me x minus 1 in the first one, plus 2x, x plus 1 in the second one, and then x minus 1, x plus 2 in the third one. So we need to do some distributing, some combining, and so on. So we have x minus 1 plus 2x squared plus 2x when we distribute the 2x. And then we're going to FOIL on the other side. So x squared plus 2x minus x minus 2. So we're going to combine what we can combine. So we've got 2x squared plus 3x when we combine those x's minus 1. Equals x squared plus x minus 2. Now in order to solve this, since we've got this blend of x squared and x's, we need to move everything to one side because we're going to have to factor, which means it needs to be equal to 0. So we're going to move the x squared to where the bigger x squared is. We're going to move the x, and we're going to move the 2. So what we get out of that is x squared plus 2x plus 1 equal to 0. And we need to factor that. Good, I can get more space. All right, so trinomial, we want to do 2 factors, x and x. We want 2 numbers that when we multiply them, they give us 1, and when we add them, they give us 2, which is going to be 1 and 1. So they're going to give us the same answer. X is going to be -1 because we would do x plus 1 equals 0. So then when we move the 1 over, that gives us x equals -1. Since they're the same factor, I don't need to do it 2 times because it's just going to give me the same answer. So I don't need to do it 2 times. The last thing we need to do is check out our restrictions and make sure that that answer is not one of our restrictions. Because if it is, that means we don't have a solution. So our restrictions would be x plus 2 not equal to 0 and x plus 1 not equal to 0. So that's problematic because the 2, we don't have that, but we do have the -1. So what that means is we can't actually use that, and we have no solution. Because x can't be -1, and that was my only answer, and it can't be that. So that means there is no solution to that problem. So it's possible that you do everything correct, but at the end, it ends up being one of your restrictions. It's possible that I might have made a mistake as well, but I'm pretty sure we're good. So you guys can double check that and let me know. All right, again, any questions, please send them my way. All right, so in this one that you can't see yet, these two, what I want you to do is pause the video, and I want you to practice doing them, and then come back when you're done and start the video again and check your answers with my solutions. So pause the video. All right, so hopefully you were able to solve. We're going to start by factoring, so we have x minus 1 over x plus 2. That one's good to go. Equals, I'm having a rough time, equals x plus 3 minus 1, because we want 2 numbers that multiply to 3 and subtract to 2, which is going to be positive 3 and -1 to get me positive 2. So with this one, there's actually a little trick we can use, which is kind of nice if you notice it. So instead of having to multiply by the denominators, if your denominators match, so I only have 2 fractions, and I have the exact same thing in the denominator. So I don't actually need to multiply by that. I can just put the tops equal. So if the denominators are the same and you only have 2 fractions, you don't have to do the whole process. You can just put the 2 top pieces equal to each other, which is a really nice shortcut when that's an option. So B, that's not an option, but A, that's an option. So do that, or if you did it the other way, that's fine. You might get an answer, but in addition to what I get here, but you'll see that it's actually one of your restrictions when you find it. So no matter if you leave it or you don't, after you do the whole process with the restrictions, it should come out the same. So we get x minus 1, and then we're going to want to FOIL that other part, which takes us back to what we started with, so x squared plus 2x minus 3. We need to move everything to one side because we're going to have to factor because of the blend of x's and x squareds. So we want to move to where x squared is going to be positive. So we have x squared plus x minus 2. So we want 2 numbers that when we multiply them, they give us 2, and when we subtract them, they give us 1. So that's going to be positive 2 and -1. So that means that x is going to be equal, x plus 2 equals 0, x minus 1 equals 0. So x is -2, and x is positive 1. But just like we did with our restrictions before, we want to take that denominator, which was x plus 2, and that cannot be equal to 0. So we'll see from that that is going to give us that x can't be -2, which means I need to take out that -2. Now in this one I still have an answer that'll work, so that 1 is fine, that's my answer. It's just the -2 is not an answer, even though it was part of my solution. When I look at my restrictions, it can't be that, so I'm going to take that out. Alright. So you don't need to write no solution because you do still have an answer that works, just to clarify that. Zoom out. Okay, letter B. So in letter B, we have different denominators there. We've got x plus 1, x plus 4, and then another x plus 4. So 2 match, but the third doesn't. So because they're not all the same, you can't do what we just did. So instead, we're going to have to factor, but if looking at those, you'll see none of them are going to factor. So we're going to start by right away just multiplying by the denominators. So the x plus 1 and the x plus 4. The x plus 4 is in 2 fractions, but it's only written once in each of those. So that's fine. So we distribute that. So we have x plus 1, x plus 4 over x plus 1 plus 3, x plus 1, x plus 4. I'm going to run out of space. Move some stuff. All right. Over x plus 4. And then, oh, here comes the real challenge. X plus 3, x plus 1, and x plus 4 also needs to fit in there. Move again. All right. And x plus 4, imagine there's a parentheses at the end of that. Ooh, I fit it. Okay. Over x plus 1, x plus 4. All right, and then we start canceling stuff out. You can do that step all in one if you want. So here the x plus 1s are going to cancel. We're going to have x plus 4 plus, in the second one, the x plus 4s are going to cancel. So we have 3x plus 1. And then in the last one, we have the x plus 4s. And I don't know why I wrote that extra x plus 1 on the bottom. Sorry about that. There's just an x plus 4. Got a little carried away. So in the top, we still have x plus 3, x plus 1. Because of just the x plus 4's cancel in there. I added an extra factor that wasn't there. All right, so then we want to distribute, we want to FOIL, everything we need to do there. So the first one's going to give us x squared plus 4x. And then the second one's going to be 3x plus 3 when we distribute that. And then the last one we need to FOIL, so x squared plus x plus 3x plus 3. We can do some combining, so x squared plus 7x plus 3 on that side, and then on the other side x squared plus 4x plus 3 on this side. So what happens when we do this is we have a blend again. So we're going to want to move the x squareds over. Don't know why I changed colors. Let's keep that the same color. So let's move the x squareds over. You can also move the 4x over because we're going to have to do that as well, and the 3. So we move everything. Our x squareds end up eliminating as well as our 3's. So that just leaves us with 3x equals 0. So we need to divide by 3. So in this one, we're going to have that x is 0. Again, we need to check that with our restrictions. So our denominators are x plus 1 and x plus 4. Neither one of those is going to give us a 0. So x plus 1 not equal to 0. It'll be okay for that one, and 4 as well. So that means that our answer is good. We don't need to cross it out. X is 0, and that's an okay answer. All right, hopefully those checked out, or if they didn't, you were able to see where you went wrong. Okay, this one is using a graphing calculator to solve. So in this one, you want to figure out where do they intersect. So to do that, what we're going to do is we're going to start by substituting into y equals in your calculator. Let me figure out how I'm going to do this. So we're going to have y equals, sorry, I'm getting into my computer. Okay, so we're going to go to y equals, and in one of them, we're going to put 2 over x plus 2 plus x over x minus 2. So where just that left side, that whole left side is going to go into a y equals. And then we're also going to put the right side into a y equals as well. So y equals 1. And then we're going to need to graph that. So I would use alpha y equals as you do that. You'll see here, I'm going to switch this to the camera. So bear with me 1 second. And hopefully this is it's not on selfie, because otherwise, Alright, so camera. Oof, yay. Okay, so there's your calculator screen as well as my house. And we want to go to y equals. So we're going to go y equals. Do it. Hopefully you guys have your calculators. If not, there's some online ones. So we're going to go to y equals. And in y equals, we're going to clear whatever's there. And then we're going to do alpha y equals n over d, because we have fractions, so we want to put in the fractions. And I already forgot what the fractions were, so hopefully you guys wrote them down. But we had 2 over x plus 2 plus x over x minus 2. So I'm going to do 2 over, x plus 2. So x plus 2. And then we had plus alpha y equals again. And again, I already forgot what the other fraction was. So x over x minus 2. Sorry, my camera is focusing here. Over x minus 2. And then in the second one, we want to put the other side of the equation. So the other side of the equation was the 1. So in that second y2 spot, we're just going to put a 1. And then we're going to go ahead and push graph. At the top there's my dog chasing a ball. And you're going to see kind of how the graph looks there. We actually get 3 different graphs, or 3 different curves. And then you'll see that red line coming through there. So what we want to do is figure out where is it crossing. And we can see that in this part here, it's not going to cross at all because there's an asymptote, as well as this part over here, that's not going to cross at all. So the only spot that it's crossing is right there. So we just need to figure out what that point is. So to do that, we're going to do second trace. You could have multiple answers here, so you might have multiple places where you need to do this. But we're going to do second and then the calc up here, like we've done for a lot of things. And we want to know where does it intersect, number 5. So we do number 5, and it's going to ask you for your first curve. So we're looking at that middle curve with the line. So we're going to make sure that the first one's on that middle blue curve, which it is. So press enter. And then it's the second one's asking for the second curve, which is that red line, which is on that. So we're good with that. And then press enter. And then it says guess, and we press enter one more time. And that says that the intersection is at 0, 1. So what that means is we're solving for x. So we want to know what the x value is. So the x value is going to be 0. So ignore those. So what that means is that here our solution is going to be x equal to 0. And we know that since the calculator found it, it's not a restriction. So we don't have to worry about checking the restrictions, but if you want to double check, you can. But again, it's just x equals 0. So that's your answer, and you're done. And there's only one spot, so you only have one answer. Again, if the calculator gave you an error at that spot, then you would say no solution, or just look at your other answers. But as long as it's giving you an intersection point, it means that it will fit no matter what. And you want the x value because we're solving for x. Okay, so go ahead and try to do this one. Put it in your calculator. You can pause the video to do that. And I will do that while you guys are working through it as well, and you can come back to the video when you have your answer. Okay. So I'm going to be working on that, so you're not going to see anything happen for a second here because I'm not going to make you bear with me typing it in. So you're going to do alpha y equals, and we're going to put x plus 2 in the top. And then in the bottom we have 1 minus 2x. So that's going to go in for y1, and then for y2 you're going to put a 5. So you put all that in, and I'll show you a picture of that. Okay. So how that should look is like that. Remember to get the fraction, you do alpha y equals, put in your stuff. So when you push graph, you can actually see down here, there's the graph. So actually I won't even push graph, it's right there. So we see there's a point where they're crossing over up at the top, and that's going to be the point we want to find. So, we do graph. Oops, quit. Don't know what I did wrong. Trying to smooth screen.